Alright, we'll start off with our most simple parts. If you don't care about how I've set up the project, feel free to skip forward to the later videos. In those, we talk about creating collision geometry from images and destroying it in real time. We'll start off with our debug camera. This is just a camera 2D, and we've set it as current, so it's what the player will be using by default. By right-clicking, you can pan it around the scene, and by scrolling you can zoom in and out. This is all controlled by a very simple script. First up, we've got a couple of variables to track the previous camera position and whether or not you're currently moving the camera. In our unhandled input, we look to see what you're doing with the mouse. If you're right-clicking, we want to update our move camera variable, and if you've just started our right-click, we want to record the current mouse position as the previous position. If you're moving the mouse around the screen, we move our camera position based on the offset since you first right-clicked. This is how we pan the camera around. Finally, we check whether you've scrolled the mouse. If you have, we'll smoothly zoom in or out. These Vector 2 parameters control the minimum and maximum zoom that the camera can go to. Note that this script is just for debugging our little project. If you were making a similar script for a bigger project, you'd want to use input mappings instead of hard-coding our buttons. The next scene to look at is our wizard. There are countless YouTube videos on how to do platformer movement, so I'm not going to cover that. Instead, we'll look at just two bits: how we move our reticule and our shooting logic. The reticule is about as lazy as we can get. It's an anchor point that defines the location that our reticule will move in a circle around. This then has a bunch of sprites for children. One of these is the reticule, and the others are the different slime images that we're going to show and hide depending on how long you've been holding down the attack button. It'd probably make more sense to use a progress texture or something, but the focus of this project was the terrain destruction, not the character. So if we look at the wizard script, every tick in our process method we call rotate reticule. This just uses a helper method to find the angle from our reticule to the mouse position. We then rotate our reticule by that amount so that the reticule anchor is pointing directly towards the mouse. This gives us our reticule that rotates around the character at a fixed distance. Our shooting logic is scattered through a lot of this script. The first part of it are these three variables. We have our attack power, which is a number that keeps getting bigger the longer you hold down the shoot button. Then there's the attack scale, which is a multiplier to control how quickly we should show the slimes while you're holding down the button. And we have our attack clicked. This tells us whether you're currently holding down the button or not. After that, there's this auto attack power. Once our attack power reaches this amount, you're going to shoot automatically. So if you hold down the button for too long, it'll automatically fire the slime. If we have a look at our unhandled input here, all we're doing is checking if you've used the left mouse button. If you've just clicked it, we set attack click to true. Otherwise, you've just released the mouse button. So if you were holding it down, we want to shoot, and then we want to set our attack click to false. We're checking this here because if you've auto-attacked and then released the mouse, we don't want to fire a second time. Next, we want to look at physics process. Every physics tick, we check whether we're holding the button down. If we are, we increase the attack power by the delta since the last physics tick. That means that our attack power is just going to keep getting bigger. If our new attack power now exceeds the auto attack threshold, we will shoot. The rest of the physics process is just platform and movement stuff, so we're going to ignore it. If we look at our physics, after rotating the reticule, we redraw power, so let's look at that next. This uses our attack power to figure out how long you've been holding down the button, and that tells us how many slimes to show. The longer you hold it down, the more slimes you get, up until the auto fire. So we just loop through all of the slimes parented to the reticule anchor, and we show or hide them. Finally, we get to our important bit, the shoot method. So this is going to happen whether you've held the button down too long or when you release the button. This spawns our weapon projectile, then sets it to the reticule's position, then we give it an initial velocity. This points in the direction of the reticule and is modified by our weapon speed and our attack power and scale. We then parent our projectile to the parent. This makes the projectile a child of the map instead of our wizard. We're doing this because all the wizard's children have their movement affected by the wizard, and we don't want the wizard moving from side to side to modify how the slime flies. Lastly, we reset our attack power and pretend that you've stopped clicking the button. So, our weapon projectile is defined up here. We also define the weapon's speed. This is just a modifier to the projectile's initial velocity. If we have a look at our wizard setup, our weapon projectile is our green slime scene, which we can see in the file explorer over here. The green slime is just a rigid body 2D with a sprite and a collision shape. This is configured so that it's on the default and destructible layers, and its mask is set to just the destructible layer. We've got a really simple script on here that's almost entirely driven by our body entered signal. So if we have a look at this, we define our explosion radius and scene, and we have our body entered callback. The first thing we do is tell the Destructibles group to destroy terrain at the current location of the slime, and we pass through our explosion radius. We'll look at how the Destructibles group is set up when we get to our real-time destruction video. For now, we can ignore it. Once we've told the Destructible group to blow things up, we spawn our explosion scene. We then parent that scene to our parent. So again, we're parenting something to the world map instead of to ourselves, because we're about to delete ourselves. When you queue free something, it deletes all of its child nodes, so we don't want to create the explosion and delete it in the same instant. If we take a look at our explosion scene, it's just an animated sprite. The images for this animation are from Kenny and will be linked in the description below. We've got a very simple script here that just does two things. When the explosion is added to our scene, we play our animation, and when our animation finishes, we delete this node. This animation finished is called from the animation finished signal. So that's our basic setup. We've got a camera that lets you look around and zoom in and out, a wizard who can shoot multiple slimes, and slimes that create an explosion animation on impact. Tune in for the next video where we're going to see how we can create a collision geometry from an image when the game starts.